Not really. Hello. Hi, everyone. So this talk is about JavaScript performance patterns with accent on patterns. So I'm not going to give you too much of do this, don't do that, because quickly gets outdated. So I'll try to teach you more about how to think about performance, how to approach the performance problems, and how to pick your battles. So before we start, there's usually why do we need to talk about performance at all? But I don't think this audience needs more convincing. But there's always this. Oh yeah. So the slides are on SlideShare. So there's a bunch of links if you want to follow along or visit later and so on. So there's this bookofspeed.com, and the first chapter is about the performance business case, and if you need to sell performance to a client or a boss or somebody who is in your way of you spending more time on performance. And what about JavaScript performance? Do we need to worry about this? So this is some stats from the HTTP archive. It turns out that after images, JavaScript has the biggest share of the average page in terms of bytes. But unlike images that are not in the critical path of displaying a page, JavaScript usually is, and it can slow the page throughout the time of the page, not only the loading stuff. So it's important to focus on JavaScript performance, and this is what we're going to do today. Talk about how to load JavaScript on a page, and then some optimizations after the script is loaded and the page is rendered. And a few words about benchmarks and Shims. And this is the about me slide that's in this one, convincing you that I'm qualified to talk about it. I hope. So before we talk about loading, and just in case if somebody is new to web performance optimizations, before you do anything else, you have to make sure that you run either YSlow or page speed or web page test, any of these tools, and just do what the tool says. Reduce the number of HTTP requests, make sure that scripts are gzipped, minify them. The gzip and minification combined gives you about 85% win in terms of byte size. Set the expires headers, use CDN if you have budget for. So the very basic things before we move along. So how the script does end up on the page is usually this pattern of having script tag pointing to a URL somewhere. And that's not the way we should load JavaScript, because that makes JavaScript a single point of failure. Because JavaScript in most browsers blocks the download of other components, and in pretty much all browsers blocks the rendering of the page. So it's in the way of when the user types the URL, visits the page. If there's a blocking script tag, this is introducing a single point of failure. And if the script doesn't load for whatever reason, you get an empty page. And this is one little tool. 3PO stands for third-party optimization. So 3PO fail is a Chrome extension that simulates what happens when Facebook and Twitter and Google and all these third-party services are down. And if you include a script with a blocking tag, then you see what the user experience would look like, which is just an empty page. And there's another extension similar to that I didn't know existed before I wrote mine. It's called Spofomatic by Pat Meenan from Web Page Test. Same idea. It just black holes all the famous third-party websites, and you see what happens when they're down. But that will give you an idea what happens with your website as well when you have a blocking script tag, which doesn't load for some reason. So we need to take JavaScript off the critical path of rendering and having the user visit and interact with the page. The way to do that is load JavaScript asynchronously. So in some future, we'll be able to use defer or async attributes, which are now defined in HTML5 proposals and whatnot. But until then, until those work, the easiest thing to do is just create a dynamic script node and include the JavaScript in there. There is this perf planet post that talks a bit more about, because this is the simplest example possible, right? But sometimes you don't control the page, you might not have a head to append to and so on, if you want to know more about this. And the objections are usually, oh, what if I have on-click attribute or some inline JavaScript and so on, and I'll say, just don't do it. You should fix those anyway. But if you really must have inline script tags, then you can simply have a queue and append all those function calls to a queue, and then once the JavaScript arrives, because it's now asynchronous, you have no guarantee that it's there. Now, when it arrives, then you can run everything. The other question is about what you do with dependencies. So usually I prefer to have a single JavaScript file, write as little JavaScript as possible, and send it once with a single file, but that's not always an option. But luckily, browsers support either onload event or this onReady state change. So it's trivial to write a function that will load, let's say, some library and then your application, and then once these are ready, both of them, and then you can run everything. The basic idea is that the page should work in as a progressive enhancement idea. It should work without the JavaScript, and whenever JavaScript arrives, everything gets much better. And Jacob after me is going to talk a bit more about dependencies. So this is kind of a poor man's if you want to load 1 or 2 files. So I'm looking forward to his talk as well. So one problem is that even if you load the JavaScript asynchronously, it will still block the onload event in all browsers except IE. And this window onload used to be something that people use a lot when they instantiate all their JavaScript on the page, but that's usually not the case anymore. But it might still be a problem. For example, if you're running some third-party analytics tool or some sort of service that doesn't know anything about your page, doesn't know when you instantiated your interfaces and so on. So any approximation that they have is the window onload. But there is a solution to that, although it's ever so slightly complicated. We'll call it FIF, or frame in frame, or friendly iframe, or this Meebo way of loading JavaScript, because Meebo was the company that first started using as a big scale, loading their JavaScript in this way. The idea is you create an empty iframe, use document write, which usually people would never do that, but in this case it's okay, because there's nothing else on the page to block. The only thing this little iframe does is load the JavaScript. So in this little iframe, you use document write to create a body tag, and onload of this body tag, load the JavaScript. So kind of a simplified example would look like this: creating the iframe, putting it somewhere, then getting a reference to its document and doing this document write, where doing this way across all browsers, the onload event of the iframe will fire, and the main page is not going to wait anymore for it. So then you kind of take completely this JavaScript out of the flow of the page, and you append the JavaScript this way. Good thing is it unblocks the onload, but as you can see, it's a little bit more complex, a little bit more code to write. And the bigger problem is that now the JavaScript is inside of an iframe, so it no longer accesses the same window and document object, and requires some JavaScript changes, but that's pretty easy to fix. So usually your script looks like this. You assume a global window and global document, and you do stuff with them. Or maybe even something like this, where you don't leak any globals and so on. Everything is contained in a closure. So all you have to do is now have a local window and document, and you just, to this closure, you pass the reference to the parent window and say, okay, this is your window, and then this is your document, and the rest of the script stays as it is. And for an example of this in the wild, so about a week ago, we added this to the Facebook JavaScript SDK. And there is this JS bin link that you can follow and see an example how to load the Facebook JavaScript SDK so that the Facebook stuff is completely out of the way and doesn't interfere with the page, doesn't block anything. And if the Facebook goes down, your page still works. So yeah, please experiment with that. Give feedback and just take it as an example of how this can be implemented in your own pages. That was all about the friendly iframes. So another thing is that I want to talk about is how you want to load JavaScript but not run it. There are use cases for this. For example, let's say you're on a login page, and while the user is typing username and password, or you can assume that they'll get their password right, and they'll end up on a page, on a different page. So you can start preloading some of the stuff for the next page to make everything faster once they land there. You can also want to lazy load some features. In this case, it's a really nice idea to be able to load the JavaScript but not run it. So first of all, the JavaScript doesn't know that it's loaded in a different page. It might assume that there's a div with ID, whatever that exists. So you don't want to run this JavaScript. And plus, you have to parse and execute it, and that slows everything down. And Massimiliano tomorrow will be talking more about lazy loading stuff. So that'll be interesting as well. So there are use cases for that. So 2 steps. First, you want to fetch the script so that it's in the cache, it's loaded, there's no network request and so on. And then eventually when you decide you want to run it. So there's many workarounds because there's no easier way to do this, unfortunately. There's some proposals for, let's say, add a preload equals true attribute to a script node that will eventually fix things. And there are many ways that people have experimented with how to load the JavaScript but not execute it. Even I've come up with some ways that are not good enough, like load the script in an object tag and then run it later, but not good enough. But luckily, there's a somewhat simple solution. Turns out that IE, hooray for IE, since IE4, and there is a very easy way to load the JavaScript but not execute it. And for all others, then you can use XHR2 cross-origin request. For that, your CDN should support access control origin. If they don't, you find another one who supports it. I think Amazon announced last week that they'll let you do that if you use Amazon to store scripts. So the kind of the snippet looks like this. So interestingly, from line 3 all the way to 10, that's for non-IE browsers. If it was only IE, it would be much simpler. So in IE, the good thing is that when you create a script node, set the source, IE starts fetching this script, even though you have not added it to the DOM node yet, to the DOM. So once you add it to the DOM, then it's going to be executed. And yeah, I learned that from a guy called Kyle Simpson, Getify on Twitter, who's the developer of Lab.js. The way to test for support is if the script node has a ready state and this ready state is not uninitialized, because I think this was Opera kind of a edge case. Then for non-IE browsers, you can use XHR, but you have to detect that this is XHR2 because it supports cross-origin requests. So the way to test is you check if with credentials exists in this object, and then you just go and fetch this file with this URL. You don't really have to have any callbacks or anything. You don't really care when it arrives because nothing's going to happen until you actually add it to the DOM. So that's nice. And that's all I wanted to talk about loading JavaScript. So let's talk a bit about what happens after JavaScript is loaded. What can you do to make things faster? And just an aside rant about benchmarks. If I can kind of misquote Disraeli, who was saying that there's lies, dem, lies, and statistics. We have lies, dem, lies, and performance advice, 3 types of lies. because it's really easy, especially in JavaScript and browsers, to test for the wrong thing, write the wrong test case, or measure incorrectly, or even if you somehow manage to do all of these, then you might come across the wrong conclusions. And there are many reasons for that. I'm not going to talk about how to do benchmarks, but that's usually what people would do, this pattern. You take a start date, you do something crazy that never happens in practice, and then you take the end time. And there are many problems with that. First, this is not the real test case to run something millions of times. Then you haven't released the UI thread. If you have any DOM operations, they might be in memory, and so on. You haven't given a chance to the browser engine to optimize the script. So yeah, there are many drawbacks to this, and I can recommend this thing called Benchmark.js by John David Dalton. It's used in this site JS Perf, so I would highly recommend spending time on JS Perf. So it's calibrating the test, so it gives you, it doesn't measure how long does it take for something to run, but it measures how many operations this thing can done in a predefined time. So it calibrates, you don't have to wait, because sometimes if you do the regular test with the start and end time, you do something that it's takes 10 milliseconds in Chrome, or gives you in IE the unresponsive script, or never finishes, and so on. They also check for because when you run a test, you want to have some statistical significant results, not just one run, and they should be repeatable. So if you run the same test twice, you should get the same result within some margin of error. And John and Matthias, Matthias is the main person behind JS Perf. They wrote in this article on Performance Planet how exactly, more details about benchmarking, and it's highly recommended. And also, I forgot to put a link, but Matthias had a talk I watched somewhere on YouTube about how to write JS Perf tests and common pitfalls and common ways to test the wrong thing. Also highly recommended. So one thing we don't want to do is benchmark the browsers. Is it Chrome faster than Firefox? And there's browser vendors who worry about these things. So for us, for a web developer, that doesn't really mean much, because you don't want to have, let's say, A and B, and you want to go this way or that way. You don't really care about the absolute time it takes in specific browser. And they have their artificial, in most cases, benchmarks. So we'll let the browser vendors benchmark the browsers. So with that, let's do some tests. There's this common advice you may have heard, that string concatenation, right? This is just an example of barking at the wrong tree. You can see this advice saying that if you just concatenate strings like this, it's slower. But if you create an array and push to this array and then join at the end, that's going to be so much faster, and everything's going to be unicorns and rainbows. So there's this test right here, the JS Perf test. I don't know if you can see, but I have a bunch of URLs for JS Perf tests where you can go and run and see how exactly the test works. And some results. So this is just because it's running in many browsers. So in JS Perf, the longer line is better, because that means it can do more operations per second. So in this case, you can see, so the first thing, the blue one, it was what people advise you not to do, the string concatenation, and the red one was pushing to an array. So as you can see, the results are mostly the opposite, sometimes not, but it's really all over the place. And the reason this advice came out to be is because of some really early IE 6 and 7 versions. Unfortunately, they're so slow that they don't look, you cannot really see what's going on there. But you don't see anything blue here, right? So that means that this advice was right at the time of IE 6 and 7. Pushing to an array used to be somewhat faster, or much faster, I don't know, but that's no longer the case. So if you just take an advice and following blindly, there's a good chance that you'll be wrong with the next release of the browser. So as you can see, IE 8 is already better, IE 9 is much better. So this is not something you should be spending time on. So when people give advice, right, they should say, oh, right, but this works in these specific browsers only if the string is this long and if you have 20 things to append and so on. So that reminds me of this quote from Terry Pratchett, right, where they wanted to have, on this quote, they wanted to have accuracy in the literature. So writers were allowed to say the pen is mightier than the sword, if they are willing to qualify that only if the sword is really small and the pen is really, really sharp, then that's true. All right. So my main point is that if somebody comes and says, oh, don't do A because it's so slow, do B and everything will be so much greater, your first reaction should be go, because you're polite, you say, you should check it again. Go check it again. Because there's a good chance that that this advice is wrong and or not as important, right? So what you should do is profile and see really what's going on. In not so distant future, we didn't have any really good tools to profile and see what goes on. But now there is in the web inspector in Chrome, there is this CPU profiler and memory heap snapshots. And there is a timeline as well, which not only gives you the loading time, but also how much time it takes to execute a piece of JavaScript, how much time it takes to paint and render this thing on the page. For IE, there's the Dynatrace Ajax Edition, free tool that does the same, gives you CPU. In addition to the network activity, gives you CPU. It's really good tool. You can drill down to the actual function and see, okay, there's something a bit longer here. Let me drill down and see, point you to the exact function and exactly what it's doing. So the main idea is to pick your battles, right? Because you might be spending time optimizing the wrong thing, and this is time that you could have spent on doing something else, doing something cool. And in a way, spending too much time micro-optimizing may be a disservice to the user because they would prefer you to do something, add a new feature, or clean up some interfaces and so on. So yeah, just profiling and deciding what to work on. The other thing about performance optimization is that sometimes they could be a bit of a pain and ask you to write more code and spend more time. So every time there's a chance that you'll be doing more work, then there should be a light bulb saying, oh, I'd better check if I should be doing this. Or as the Crockford says, make it right before you make it fast. So if you think it will take a while to do this optimization, just consider if it's worth doing. The other thing is about DOM. Most often when there's a problem, it's either, and it's not in the way JavaScript is loaded on the page and delivered to the page, it's usually DOM operations. And this is proven time and time again to be the case. It's either painting something or doing too much stuff on the DOM, which is much different than optimizing loops or string concatenation. So there's this little test that I did just to prove how slow DOM operations really are. As you can see, it took me 4 iterations to somewhat get that right, so it's not easy to get something as simple as this. So let's say you have a div element and you want to add some content to it. You can do it like this, right? Because it's easy. Or you can do something that requires more lines and do all your HTML, anything you do, and append it once at the end. So this simple test you can go and run, and these are the results. So the red is the string operations in memory and not directly in the DOM. So as you can see, it lets you do much more operations per second. So it's anywhere between 5 and 75 times faster to do the first thing. This little simple thing that could be just a big pain compared to doing it in a local JavaScript variable. And so we're not talking about 20% slower or 80% slower. We're talking about 75 times slower. So it's just insane how slow this thing is. And just to put the things in perspective, a little bit different version of the same test where I put string concatenation with strings or array concatenation, these old tests that I said you shouldn't bother with. And they could be different in some browsers, but still this is, in the worst case, this is 2 times slower, but it's still 75 times faster than doing everything in DOM. So you can clearly see where you should be focusing on and what you should just leave out and aim for maintainability and readability. And there was one talk from Microsoft where they introduced this really nice comparison. So when you do something with the DOM, that you can imagine this being having a toll bridge between the JavaScript land where you do loops, functions, objects, and so on, and going to the DOM with something like document dot anything really. And every time you cross that bridge, you have to pay a toll fee. So the more you cross that bridge, the more often you cross, the more you pay. And this is the most advanced slide that I've done in my life. So this is the toll bridge, and then you come from JavaScript and say, I want to get a reference to the DOM. Then you're lost in the DOM land, and eventually you come back. And the more you do it, then the slower everything gets. Even proven with this simple example. So how to improve the performance in DOM manipulations? So first of all, yeah, you should never go and say document get element by ID dot style dot something. Document get element by ID something something. So if you want to work with one DOM reference, with one DOM element, you get a local reference, you do everything in there. So you end up crossing this bridge fewer times. So when you have a collection, when you loop over a collection like something returned by get elements by tag name or get elements by class name, when you want to loop over all these elements and do something with them, it's a really good idea to cache the length of this in a local variable. It's also kind of a good idea to do it in any loop, but some recent improvements in V8, for example, makes that unnecessary. So for regular loops, probably you shouldn't bother with that. But for collections of DOM elements, it's a really good idea to cache the length of the entire collection. And the reason is because this collection is live. So every time, for every iteration of the loop, the browser will requery the DOM and see if, let's say you have done document get elements by tag name div, and you loop through that. So every time, for every iteration of the loop, the browser will go and fetch go to the live document and give you the most recent version of the document. So caching the length is important. That's not really the case when you use query selector row, because query selector row doesn't return a live version of the page. So you don't have to do this, but using query selector row for simple things like things you can do with get by class name or by tag name, if you do it with simple queries with query selector row, they'll be slower because you have to fetch that live thing and make it a static list of DOM nodes. If there are many changes that you have to do, let's say there's a section of the page that you want to update, really good idea to do those, let's say offline. You create a document fragment, then you append to this document fragment, and once you're done, you've constructed some chunk of a tree, then you put it in the live DOM only once. So you cross that bridge only once. Same with style changes, right? If you want to do element dot style dot background color equals yellow and dot style dot font equals whatever. So it's a good idea to modify the CSS text or just use a class name, but you use a string of CSS properties and do them at once instead of every time. Style changes, again, if you yeah, that's what I was talking about. And reducing the reflows in repaint. So you're probably familiar with the concept of repaint is when something on the DOM changes but doesn't change the geometry. Let's say background color changes, but the geometry of the page still stays the same. This has a certain cost, but the more expensive is the reflow when you say add a little bit of padding or add something new to the DOM. Then you're invalidating part of this render tree, and some geometry needs to be recalculated again, and this is known as a reflow. So reducing the number of those is a good idea. So reducing the reflows is if you do all the operations in outside of the live DOM, and then you append them once, that's only one reflow. But you can, because browsers know this is expensive to recalculate those dimensions, so they optimize for this case. And when you want to have a bunch of little changes, they will put them in a queue, and once they decide, they'll flash this queue of changes you've requested only once. So the browser's already doing something for you, but you can invalidate their optimization by excessively asking for computed style, which is this get computed style or current style in IE. Let's say when you want to change the same property 3 times, so this will be queued and then executed only once. But if meanwhile you want to ask for something, for some computed style, even if it's unrelated, then the browser will have to flash the queue of things that it has prepared, and this thing will cause these styles to be recalculated 3 times instead of 1 on here. And these screenshots probably you cannot see much, but this is from a tool called Speed Tracer, another extension for Chrome. It's built into Chrome, but you cannot see, but you have to trust me. So if you do it like this, then you have only one. Let's say I've clicked on a DOM node, and then I have the styles were recalculated once, which means the paint stuff, and then the layout, which is the reflow thing, the recalculating the dimensions, is done once, as opposed to 6 times in this other case where you're in the way of the browser by asking for updated information. The browser has no other way but to flush the queue, because you want always the last most accurate value. All right, something kind of newer, data attributes. People find it really convenient to use data attributes. So I was just thinking how bad it is, because it smells DOM-y, right? Because it's in a DOM element here. So is it really a problem or not? So there is this new thing called data set. So when you have a reference to an element, then you can have a data set of all the data attributes that you have added to this node. And for all the browsers, you have to do get attribute and take your property. Because this data set is an object, so you can have multiple data attributes, and you get an object, a data set object. For all the browsers, you have to do get attribute. Or how about if you do it yourself, which means come up with some small utility that collects the data and get that data from your div that you want. And this is how I implemented this really simple thing. So this is some data utility that has set and get methods. So when you want to write to this data, instead of creating a new data attribute, you just set some data, which is an object. I will check, I'll have a custom property in there, set data, and this I need some sort of identifier, which is just a simple count. And then I'll use all the data, I'll store all the data in this local warehouse variable. And then when you want to get data from there, you just check here. You don't go to the DOM at all, because it's already there. And the test, I didn't put the URL. No, I did. All right, so this is the test, what I was testing, the old way, this set attribute, get attribute, the do-it-yourself approach when you have a utility, and then the data set. So I was expecting this to be slow, but didn't expect that this thing is so much slower. So as you can see, 8 million operations per second as opposed to 1 million or even less with the data set, which was really disappointing because it's kind of shorter. And the JS perf test is right here. You can see, you can check it out later, and you can see again, longer is better, and consistently across all browsers. This is iPhone here. Consistently across all browsers, do-it-yourself data storage is unfortunately so much faster. Hopefully things will improve, but for the time being, if you use data attributes a lot, you can consider a little utility like this. All right, just a few words about polyfills. They're really popular lately because they're really convenient, but you know, just common sense, not to add too much load because of a shim or a polyfill. Like, for example, PNG, transparent PNG support in IE6, right? This adds another request and so on, and makes everything much slower. So you can see that those shims or polyfills are correctly written. They work correctly as they were supposed to, and common sense tells you that you should pick those that use the native stuff when it's available. Let's say you have a ECMAScript 5 shim to add array map to all the array objects. So that the shim, the polyfill should check if the native array map exists and use this. But I have a star there because that it's not necessarily the case, although it sounds like common sense, right? And try to load conditionally when you can detect that the browser supports a certain feature. JSON is an example. I look at this website, HTML5 Please, which has a link to some statistics, and it seems like the native JSON is these days is available in 92% of all the users out there, but we're still sending it to 100% of the users. So why are we punishing all those users by giving them extra JavaScript to parse and execute when they don't need it? So this is kind of tricky because, I mean, are you doing the detection on the client side, which could be more expensive and you need a whole script to detect stuff, or using it on the server side? Yeah, up to you. So this is the thing about the ECMAScript, the same guy, John Dalton, with the benchmark in JS Perf. So he was showing this example how the native array map and for each could be slower than if you just do a regular loop. And he said this is because the browsers compete with each other with all those benchmarks, which not necessarily test the most use cases, and all those browser benchmarks have big loops, and that's why the browser vendors spend a lot of time optimizing loops, and their loops are really fast. But then when you have a native array map or for each, it might not be as fast. So the blue one is array for each, right? Pretty slow, and this is the regular for loop is the yellow one. As you can see, Firefox, so much faster to loop the old school way for var from 0 to the length and so on. Then I'm not saying you should do this. I'm not saying you should work against the browsers, but I'm just saying that sometimes it makes sense that the native array map will be faster, but in this case, in some browsers, if you implement the array map yourself, you might get a better performance. But again, this is not something you should focus on. So I was wondering about a popular polyfill to test, and it seems like jQuery is also a polyfill, right? It abstracts quirky stuff in IE6 and gives you a consistent API. It's not, I mean, it's not standard or anything, so I don't know if it's really the definition of polyfill, but again, something you use to protect you from other browsers. So the question is, do you really need it? Because it's not free. If you just drop the jQuery on the page, you're already incurring some cost. And this is Toby, guy from Switzerland, wrote this post where he was testing how long does it take just to parse and execute jQuery. not talking about loading, then network is out of the way. Just after it's there, how long does it take for the browser to parse and load? And the results are kind of surprising. So this is iPhone 3, where, I mean, in the regular browsers, you probably not notice anything, but for mobile with, you know, their restrictions, it takes almost a whole second on iPhone 3 just to parse jQuery library, right? So even in iPhone 4, he discovered 300 milliseconds, which is a lot. I think anything above 150, 200 milliseconds, it's noticeable. There was one test where you just have a button that sleeps, doesn't change immediately, so just to see what the perception is. And most people, so there's one button that reacts immediately, one that waits for 50 milliseconds, 100 milliseconds, so most people after 150 to 100, they start noticing that the interface is sluggish. So to me, 300 milliseconds is a lot. So yeah, have in mind that jQuery has a lot of things for IE which you don't necessarily need in a mobile browser. So I just did this quick experiment comparing jQuery and Zepto, which I haven't used it, but its developer says that he tried to match the jQuery API as much as possible, and it's focused on mobile browsers. It's not going to work in IE. I tested it, it doesn't. So it's just for WebKits out there. And what is the cost of doing this? And you can go, if you have a phone, like, because I only tested with iPhone, but if you have a phone now and go to this URL, jsperf.com/zepto-jq-eval, that'll be really nice to see some results from other browsers. So if you go there and just have a little bit of time, JSPerf, what is it? Zepto-jq-eval. So this is really a really simple test. I just dropped the whole library and the whole jQuery in there. That's why the test looks kind of ridiculous. And there's a run test thing here. So if you have an older iPhone, I couldn't find mine. iPhone 3, the kids have put it somewhere, I don't know where. Yeah, if you can go to that Zepto-jq-eval and just click run and see if we can get some more results. That'll be nice. So yeah, just showing you that I dropped all the code there. And this is the browser that I tested. So Zepto is meant really for mobile browsers. So this is how much slower it is to just drop jQuery instead of a smaller, more specialized library. First of all, it's smaller, and second of all, it doesn't do a lot of IE related stuff, and this could be much faster. So this is the important. I mean, Opera is something failed to run, so I guess Zepto is not tested on Opera, but this is a bogus result here. But on the iPhone, this is iPhone 4 running 5.1 OS. You can see that the again, longer is better. This is Zepto. It's so much faster to use this smaller library. And yeah, on the iPhone, yeah, because the JSPerf gives you this graph, but it can also give you a table of results and so on. So it gives you the number of operations per second, and in this case, I managed to have only 4 operations per second, which means about 250 milliseconds to just parse and execute jQuery. So let's see if some of you managed to run the test. We have more results, like Android. Still running? Yeah, hit run test. Or I don't know, it has to prepare it a little bit, so it might take a while for the bench. All right, let's see if we have some. This is jQuery. All right. At the end, it gives you It gives you, because JS Perf sends all the results to Browser Scope, which is a really nice service that you can use for those sort of testing. We have something interesting. Okay, there's iPad, which has 6 operations per second. iPad 6. No, 24 operations. All right. So yeah, it's not. Sorry about it. All right. Yeah. So IE, as you can see, in IE, Zepto failed to run because it's in i6. It's not tested there. I don't have any Androids. Let me just refresh this thing. Can I? Yeah. It's. All right. Let's see. I'll just look only at the results. Excellent. Android 3.5. Android 4, 3 operations for jQuery. So it takes, what is that, 330 milliseconds. That doesn't count networking or anything. Right? iPhone 5, iPhone 4, these things are still running, I guess. Yeah. So pretty bad in Android, looks like. So I'm yeah, okay, you can stop. You get the point, right? So I don't know. I cannot vouch personally for this library, but if it does the same as jQuery but specialized for WebKits, and it can serve as a drop-in replacement, that seems like a nice, easy win there. Yeah. So to summarize, first let's take JavaScript off the critical path of loading and rendering the page, because for most websites, people want to see some content and they're happy if the interface is not as responsive as you want it to be and shiny and enhanced by JavaScript. So whatever JavaScript arrives progressively enhances the page, but just leave it off the critical path and you can do all those little tricks. I really like to encourage you to practice writing JS perf tests, and you just say, I mean, somebody says this is fast, and just say, show me the JS perf URL. Otherwise, you know, it just doesn't mean anything really. It didn't happen. So yeah, remember the bridge every time you do document.something or element.something. Remember that you're paying the toll crossing the bridge. And yeah, before spending any time optimizing stuff, just use timeline in Chrome, the CPU profiler, speed tracer, or Dynatrace in IE. Just see where the bottleneck is, right? So you don't spend time unnecessarily optimizing for the wrong thing, and you can spend about a week, and at the end, you haven't accomplished anything. I think IE people, before working on IE9, I think they did some research in the most popular websites and where the time is spent. And it seems like the JavaScript, the ECMA script, the actual JavaScript language was responsible for really a tiny amount of the time. So as the Crockford was putting it, if you make JavaScript infinitely faster, the internet and all the websites will work about the same, because that's not the bottleneck. And usually it's the DOM, because that's all the painting and rendering and stuff that takes more time. And of course, all the network, but you know how to optimize in gzip and so on. And yeah, think about the mobile stuff, because you know, jQuery takes nothing in Chrome, but as you can see, it might be 200, 300 milliseconds on a mobile device. And thank you for that. These are the slides, and yeah, come talk to me or ask any questions anytime. All right. We have time for questions now? Yes. Well, Jasmine and stuff, it's more for integration testing, for unit testing and so on. But asking if if I have a sort of a process that every time before a push, you run a bunch of tests and so on. Yeah, there's a bit of that, but usually you can see how the page behaves, right? And you can see immediately if there's a problem with any interaction and so on. And then you just start profiling. No, not really. No. So the question was whether or not I personally use Jasmine or JUnit or something to find performance regressions, and the answer is fortunately no. I agree it's a good idea, right? But not really. What about yourself? About integration or about performance testing? Yes, perfect. Excellent. Yes. Mm-hmm. Well, if there, you certainly not pay the price for yeah. So the question is instead of using local modifications when you have a certain DOM element, you would first take the document, hide this element, take it off of the painting and rendering tree, do all your changes there, and then put it back. So certainly you're not paying the price for recalculation and painting every time. But about the DOM, it will sound, because it's still a live DOM node, right? So I know you have to write a JS perf test and show. Excellent. Thanks. Looking forward. Yes, please. So the question was when you, because, what's your name, sorry? Because Jonas is writing really computational heavy JavaScript for sound, right? Graphics, all right. And he really wants to optimize JavaScript, and he notices that when you have one JavaScript, one run in JS perf, it varies widely than if you do several runs. So that means you're running the same test several times, and you get different results. Mm-hmm. So it sounds like it's possible that you're hitting some optimization in the browser, right? That when you do only one run, then you don't, right? Do you notice this consistently across browsers, or you test only Chrome or? Mm-hmm. And then just should be. Mm-hmm. Interesting. So yeah, I think John Dalton will really want to talk to you and see what's up with this benchmarking. Yeah. Unfortunately, I have a answer to that. All right, thanks very much, and yeah, I'll talk to you later at the party and tomorrow and anytime. Sure.
We'll continue in about 5 minutes with the next one. Parties today, you know that?